friends, today I am here to discuss one topic from transportation engineering. So the topic is transition curve. So I'll discuss this particular topic in detail, right? Now, what happens is whenever we are moving on a particular highway, especially when we are moving on a horizontal curve, so what happens is on a horizontal curve we have to provide a super elevation. Right? Super elevation is nothing but it is, in simple language, it is the raising of the outer edge with respect to the inner edge of the pavement so as to counteract the effect of centrifugal force. Right? That is on a horizontal curve. Now, what happens is when we are moving on a straight highway and then there is a circular curve ahead. So directly we cannot just connect the straight curve and a circular curve. What I am saying is, let us suppose this is a straight curve, this is a straight road, then over here, somewhere over here, there is a circular curve. Now I know that after some distance, there will be circular curve. And if we are providing a circular curve, definitely we have to provide super elevation. Right? Now what happens is, in simple language, when you are providing super elevation, that means your pavement was straight. Now it is slightly inclined in the transverse direction. It is slightly inclined, right? So directly after the straight curve, if I connect the circular curve, it will not be a smooth riding conditions for the vehicles or for the drivers, right? Just imagine this is a straight line, and this straight line is immediately connected to this kind of a geometry, slopey kind of a geometry. Obviously, you will feel some jerk while riding on this particular geometry. Right? So what we are doing is in between these two curves, we are providing one more curve, right? And that curve which we are providing, that curve is known as transition curve. So in between these two, so this is a straight curve, this is a circular curve, and in between these two curves we are providing transition curve. Now, if you are providing a transition curve, what is the purpose of doing that? Why we are providing this kind of curve, right? So what happens is, say here, this is a straight curve, and the radius of the straight curve, I suppose you know very well, the radius of the straight curve, it is equal to infinity. It is infinity. And then this is a circular curve, that means it is a circle, right? Something circular. So if this is circle, that means it will have some finite value of radius, some value r, right? Now what happens is, this is infinity and this is a finite value r. With the help of transition curve, what we are doing is, we are gradually decreasing the radius from infinity to r, to a finite value. Slowly and slowly we are decreasing the radius from infinity to a finite value r. Now what is the purpose of this? It is the simple purpose that on this particular circular curve there is an effect of centrifugal force. Definitely there will be a centrifugal force which will act on the vehicle, right? Now what we are doing is, since you are gradually decreasing the radius from infinity to a finite value r, we are slowly increasing the value of centrifugal force, right? By on a circular curve, there will be some centrifugal force. So instead of introducing the circular curve over here, instead of introducing immediately all the centrifugal force, what we are doing is, through this transition curve, we are slowly, step by step, increasing the value of centrifugal force. And how it happens? It is very simple, that let us suppose P is the centrifugal force, which is given as mv square divided by r, right? Now, when you are moving on a straight track, when you are moving on a straight highway, we never feel that our vehicle is going in the outward direction or in the inward direction, right? When we are going straight, there is no force acting in the transverse direction. But when you are moving on a circular track, you feel that you are going outward. That force is centrifugal force. That means on circular curve, there is an impact of centrifugal force. So, see here, P equal to mv square divided by r. R is the radius, v is the speed, and m is the mass of the vehicle, and P is the centrifugal force. So, r equal to infinity. If you substitute r equal to infinity over here, r equal to infinity, that means this P value will be equal to 0. And rightly said, on a straight curve, on a straight highway, we never experience this kind of outward force, right? But when you are moving on a circular track, now from infinity to r, decrease the radius. When your denominator value is decreasing, when it is decreasing, so this was infinity, now it is capital R. When it is decreasing, this numerator value will increase, right? And what we are doing is, now the radius is r. So what we are doing is, we are gradually increasing this particular force P, right? So one thing is that with the help of transition curve, we are slowly increasing the effect of centrifugal force. And by the time we reach over here at the starting of the circular curve, we make sure that whatever is the full value of centrifugal force, that is attained over here. The advantage is, it has a smooth riding effect. You do not suddenly feel that you are going outwards, right? Slowly we are increasing the pressure, force, so that on a circular curve, you do not feel that particular discomfort conditions. One reason is that. Secondly, what happens is, again on a transition curve, on a circular curve, we have to provide super elevation, right? And we cannot just directly connect this point to this point. Again, it will cause some discomfort condition. So what we are doing is, we are providing a transition curve, and on transition curve, slowly we are raising the outer edge of the pavement. And till this particular point, the point where the curves start here, we will make sure that the full value of super elevation is achieved. Full super elevation is achieved at this particular point, right? So, second thing is this one. So, full value of super elevation is achieved. And how we are doing it? Let us suppose I am taking a random value. On a circular curve, we require a super elevation of 7%, right? That means, if you travel 100 meters, the rise should be 7 meters, right? So, what happens is, on a circular curve, the required super elevation is 7%. Now, directly I cannot provide 7% of super elevation over here. What I will do is, I will gradually increase the value of super elevation. How? On a transition curve, let us suppose this much distance. I moved 1 unit. I raised the pavement slightly by 1 unit. Then again on till this particular place, again I moved some distance. Again 1 unit. Again some distance. Again 1 unit. So like this, with the distance, with the entire length of the transition curve, I will slowly raise the outer edge of the pavement by significant units, so that till my circular curve starts, it attains the full value of super elevation which is required on that particular circular curve, right? So as to ensure the safety of the vehicle, right? So this is the advantage of providing a transition curve. And secondly, when you are going like this, it also enhances the driver to turn the steering very slightly. For smooth riding condition, suddenly you don't have to turn the steering, right? Since you have some extra length, gradually you can tilt or slight tilt of the steering, and you can move on that particular transition curve very easily, right? So considering all these factors, we are designing this particular transition curve, right? So these are the objectives of transition curve. The first one is to gradually decrease the radius from infinite value to a finite value r. Second is to gradually introduce the centrifugal force. Third one, gradually introduce the super elevation on the transition curve so that we have the full value of super elevation on a circular curve. Then we have to enhance riding condition. There should not be any problem of discomfort while riding. And last one is it improves the aesthetic of the alignment. Right? So these are the objectives of providing the transition curve. So now next is types of transition curve, right? So we have three types of transition curve. The first one is spiral. Second, lemniscate, and third one, cubic parabola. So we have three types: spiral, lemniscate, and cubic parabola. Right? Now what happens is, what we are doing is, according to IRC, what IRC says that we always prefer this kind of a curve, spiral. IRC recommends spiral curve. And what is the reason for that? IRC says on a spiral curve, the rate of change of centrifugal acceleration is constant. Right? Now what is centrifugal acceleration? Nothing. We know that P equal to mv square divided by r. So this v square by r, this terminology, this is your centrifugal acceleration. Right? Centrifugal acceleration. And what they are saying is, on this kind of a geometry, the rate of change of centrifugal acceleration is constant. That means for a stretch of 100 meters, right? For a stretch of 100 meters, if this acceleration is changing by 1 unit, then for the next 100 meter also, it will change only by 1 unit, right? So the rate of change of acceleration is again constant. So what we are doing is, again we are gradually introducing the centrifugal force. Let us suppose for 100 meters, the rise or the increase in the centrifugal force was some 10 units. In the next 100 meters, again it will be 10 units, right? So by this again we can confirm that the rate of change of centrifugal force is gradual on the transition curve. Hence, this kind of a geometry is preferred by IRC while designing a transition curve on a circular track. Then the next topic in transition curve is length of the transition curve, which is important for gate point of view also. There are chances that we can get questions from this kind of topic, right? So, on the basis of three criteria, we are determining the length of the transition curve. And the three criteria are, the first one is on the basis of rate of change of centrifugal acceleration. Second one is on the basis of rate of change of super elevation, and third is some empirical relationships which are given to us. So on these three bases, we are determining the length of the transition curve, right? So let us see the first condition. The first condition is rate of change of centrifugal acceleration. So rate of change of centrifugal acceleration on this criteria, the length of transition curve, it is given as V cube divided by C into R, where V is the speed, R is the radius, and C is the rate of change of acceleration or centrifugal acceleration. Centrifugal acceleration, right? So this is rate of change of centrifugal acceleration. We know that acceleration is what? Meter per second square, right? It is the rate of change of centrifugal acceleration. So the units is meter per second cube with respect to time. Acceleration is changing with respect to time, so meters per second cube. It is also known as jerk. This C is also known as jerk, right? And to calculate C, the expression is 80 divided by 75 plus V in kmph. From here we'll get the value of C, and normally the value of C will be in the range of 0.5 to 0.8 generally. C will be in the range of 0.5 to 0.8. So on the basis of this criteria, this is the length of transition curve. Second one is on the basis of rate of change of super elevation. So again in this particular thing we have two cases. First is when the pavement is rotated about the inner edge. So in that case, the length of transition curve is given as E into N W plus WE, and the second case is rotation about center. When the rotation is about center, LS, it is equal to En W plus WE divided by 2. It is En W plus WE divided by 2, where E is the super elevation, capital N is the rate of change of super elevation, W is the width of the pavement, WE is the extra widening which is provided on the circular track, right? Now, this value of capital N, this is equal to 150 for plain and rolling terrain, and this N is equal to 60 for hilly areas. Right? So whatever is the condition which is given to us in the question, according to that we will apply any one of these formulas. We don't have to apply both these formulas. He will say in the question, consider the rotation about inner edge or consider the rotation about the center. So according to that we have to take either of the one formula. Right. So this is the second condition. And then the last one is third condition is based on some empirical relationships. So again here in empirical relationships we have two cases. First one is LS equal to (2.7) V square divided by R, where V is in kmph. This condition is for plain and rolling terrain, and then second one is Ls equal to V square divided by R. This particular case is for hilly regions. So again in the question he will mention what kind of terrain you are having, whether it is a plain terrain or it is a hilly area, right? So accordingly you have to choose either of the one formula. Now, on the basis of three criteria, we are determining the length of the transition curve. Now, which length we have to take? We have three cases, three kinds of length we will get. What value we have to adopt? So, we will adopt that value Ls or Ls will be maximum of 1, 2 and 3. So in whichever case we are getting the maximum value, that value will be the length of the transition curve, right? And we don't have to apply all the 5 formulas. The first one was on the basis of rate of change of centrifugal acceleration, one formula from there. From here you will choose one formula according to the question which is given to us, and from here also again you have to choose one specific formula, and on the basis of 3 calculations, whatever is the maximum value, that will be the length of the transition curve, right? So this is how we are calculating the length of transition curve. So this was a small description of the transition curve. Thank you.